But I thought I'd just spend a few minutes looking at an issue with FDM printing that I came across some time ago with regard to accuracy. So let's share my screen a moment. So, as I say, FDM, we know it's affordable and we know it's quite fast, but it can introduce dimensional inconsistencies. And I found that I was getting very good X and Y repeatability and as accurate as I wanted. I found the Z-axis was the one that was playing up. And I think the accuracy there can be categorized in three areas: improper layer height selection, poorly managed seam placement, and chatter from sudden changes in direction or mechanical instability. So let's go a little short PowerPoint which I'll talk to just to go through these points. Let's just get so okay, layer height. Now it's not something that I've looked at, and I would suggest it's probably not a lot you've looked at. Quite often we might go in and reduce the first layer height to maybe half its value to avoid elephant's foot, as it were. But the layer height that's finer, so if we had a 0.1 or 0.2 layer height as opposed to say 0.3 or 0.4, it will increase the accuracy of the print, but not always. We can see there finer layer height will result in the ability to fit material into tighter sections along the XY plane and can improve the overall surface finish of the part. But with respect to the Z-axis, this may slightly affect critical geometries. So what I've got here is a box, and the box is printed in the orientation that it's shown on the screen, with the flange area on the bottom. And both the hole and the slot are critical in their sizes. The holes are 21mm diameter and the slot is 17mm high. And I want both those dimensions as accurate as possible. Now, if I work with my normal 0.4mm layer height, the hole will end up being 21.2 or 20.8, which I'll come on to in a moment, and the slot will be 16.8 or 17.2. Starts to make a difference when you're fitting parts together. Now, the reason for this primarily is, if you think about it, when you set your layer height, the first layer will be printed at, let's say, 0.2mm. Every other layer will be printed at 0.4mm if it's set to 0.4. Now, 21mm cannot be divided by 0.4 equally. So it will either print one layer less and end up at 20.8, or it will print one layer more and end up at 21.2. Depends on your slicing software which way it goes. The Prusa slicer that I use will end up printing one layer more. It rounds it up. So the hole ends up being 21.2 and the slot becomes 16.8. I hope that's understandable. The overall height, where's my mouse gone, from the bottom to the top, if that was important, then of course the 0.2 first layer comes into play as well. So let's have a look. So what I'm saying is that choosing a layer height divisible by your critical Z dimensions. What you have to do, I think, is you have to plan this at the design stage so that you know what your printer's doing. So you're designing your Z dimensions to be divisible by the layer size or the layer thickness that you intend to do. Otherwise, you will get this, in my case, it's always over, because it will always round up to the next layer, and that can be as much as 0.3 millimeters if I'm doing a 0.4 millimeter layer height. So you can see the z-axis starts to be important, and you should take it into account as to what layer height you want when you're designing the part, if the part has got critical Z dimensions on it. I've not found an issue with X and Y in the same way. That seems pretty good, and I think that's probably not a lot you can do, because that's going to be based on what the printer's capable of and the resolution of the printer. So let's have a look now at seam placement. When the printer is printing a circle, it will start printing, you can see my mouse hopefully, it will run around and then move to the next layer or the next path, whatever. So you end up with this seam down the inside of curved parts, which again can be difficult if you're fitting parts together. It will occur with things like holes and complete circular or elliptical things more than anything else. And I think if you've got that situation, then you have to think that if you want a good fit in there, then the answer, which I tend to do, is to make the hole that slightly smaller and then pass the right size reamer through it to ream it out to the size you want. If it's, let's say, a 5 millimeter hole, you only need printed at say 4.9 and then pass a 5 millimeter reamer through it. Otherwise you'll find those seams will be difficult. Printing holes that are horizontal or vertical, I should say, let's just go back again, in this direction, then you may read as well, it can be common practice on this one to actually, at the top in particular, so as you don't get a bump there, to actually put a recess, a small hole recess in there, which stops that bump and seam from forming. Then the other bit that comes into play is what I'm calling mechanical chatter. And chatter refers to vibration marks or ripple effects that you can see there, particularly around curves and corners. And this is caused by the print head, that the head ramps up and slows down. And this movement of the extruding filament may be slightly out of sync, which can result in channel marks around the curve. Chatter is quite visible, and to get rid of it, then really the best way is to slow your print speed slightly, particularly if you want high precision parts. If you're doing draft mode stuff, then none of this really applies. And also keeping the printer clean and maintained, ensuring that occasionally you put some lubricant on any screw threads you have. You run round with the Allen key every now and again to make sure things have not worked loose. And in particular, if you've got a belt drive like you have on the Prusa, then the belt will stretch with time, not greatly, but again, it is worth just checking that the tension of the belt is up to what it should be.